Greetings. In this lesson, we'll learn about infinite series. This is an important topic in mathematical physics, engineering mathematics, and mathematics as well. Basically, in this lesson, we'll learn about some very basic concept. What we have already learned, this is a revision kind of lesson. So let's start. And for your convenience, we have attached the study materials in description box. The sequence, first we have to learn about the sequence. The sequence is a succession of terms formed according to some fixed rule is called sequence, like 1 2 3. This is formed in some fixed rule, like that is every terms we get, that is the one plus of the previous term. And another example, 1 x square x cube. Look at this term, every terms we get is x times of previous term. So this is all called sequence. If we add the sequence, get the sum of individual term of a sequence, then it is called a series. Like we have a sequence, and now we added all the terms 1 plus 1 x square plus x cube and goes on. This is called a series. This is basically sum of individual term of a sequence. Now, two type of series we will learn. One is finite series and another is infinite series. If the series contains finite number of terms called finite series, like have an example 1 plus 2 plus 3 plus 4. This series contains 4 number. So this is a finite series. But if the series contains an infinite number of terms, this is called infinite series. Like Sn is equal to sum up from n is equal to 1 to infinity ui. That means this series is u1 plus u2 plus u3 and goes on to infinity. So this is called infinite series. Now we'll learn about the classification of infinite series. The convergent series, if a limit of a series tends to be finite as the number of terms tends to infinite, then it is called convergent series. Look at that series. If n tends to infinity, then the whole term Sn will be tends to finite. And so that will be a finite number, because these terms will be gradually lowered down, and that will get more small to smaller. So it will be we will have an very small number and a finite number. If we sum all the number, then we will have a finite number. So this is a convergent series. But if a series tends to be infinite, as the number of terms tends to be infinite, then this is called a divergent series. Look at that series. S is equal to 1 plus 2 plus 3 plus dot 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 plus n. Look at the series. Look, this summation will be infinite. So this is that is called a divergent series, because the limit of the series tends to infinite as the number of terms tends to infinite. We'll learn another interesting series, that is oscillatory series. What is oscillatory series? If the number tends to infinity, but the series does not tends to any unique limit, this is called an oscillatory series. Like 2 minus 2 plus 2 minus 2. Look at the series. If for every odd number, that the sum of that series is 2, but for every even number, that will be 0. So that does not have any unique limit. So this is called oscillatory series. Now we'll learn about a very important series, that geometrical progression series. GP series or geometric series. This series is in the series in which the ratio of successive term is same is called geometric series. Look at Sn is equal to a plus ar plus ar square plus ar cube plus goes on to ar n to the power minus 1. Look at the series. This series, every time we go to next sequence term of the series or the next sequence, we just multiply r with the previous term. This is called geometric series. The sum of geometric series look like this. We can easily find how it is achieved, like just multiply r with the both side of the term. Just multiply r with the both side of the term, and then subtract from one to another. You will get this. Now we'll consider three important cases about geometric series. First, if mod of r is less than 1, then what will happen? Look, this is r to the power n. If this r is less than 1 and n tends to infinity, then this term will be very small, that could be negligible. So we will write this term as a by 1 minus r. By 1 minus r, this term is finite, so this series is converges. Again, if the opposite things happen, that mod of r is greater than 1, then what will happen? Look at that. If it is greater than 1, then that will be going on more and more. So this term will be an infinite term. That will be an infinite term. So this is that sum will be also an infinite as n tends to infinite. So that will diverges. So that will diverges. And case 3 is also very important, that if if this r is equal to minus 1, then what will happen? For the first term, the a is the same a, but for the second term, if it's r is equal to minus 1, then it is minus a. For the third term, it is again plus a, and fourth term minus a, and that will be going on. So so a minus a plus a, and that will be going on. For every odd number, the sum will be a, and for every even, the sum will be 0. So it does not have any unique limit, so it is an oscillatory series. Coming up, we will in the next lesson of this part, we'll learn about some important test, integral test, and some more important test, and we'll solve some problem too. Thank you. For your convenient, study materials is attached in the description.